First of all, I'd like to thank you all for being, if you were there at the party yesterday. Thank you for listening to our band. We had a lot of fun. Hope you had too. So today I'm going to talk about something I call continuous security in the cloud. That can be a lot of stuff. First, a little bit about myself. I'm a programmer working at Bekk Consulting, which is a consulting company in Norway, working for both the public sector and the private sector. I'm also quite active in the community, so I'm the founder of DevOps Norway Meetup and also organizer of DevOpsDays Oslo, which we held in Oslo for a couple of weeks ago. Currently, I'm working as a tech lead for the team that are developing all customer-facing applications for the Norwegian Railways, NSB. And this talk is sort of an experience report from that work that we did for the Norwegian Railways. So what we've done is that for the last year and a half or so, I've been working on migrating NSB's services from internal infrastructure and onto AWS. And just after summer, we moved the last application over. And I must say that this has been one of the most exciting projects that I've been on, because quite a few companies are quite reluctant when it comes to the public cloud. So but we managed to convince them, and we had a lot of fun on the way. So what I'll be talking about is the practices, the services, and the tools that we have used, and how they support a steady and fast flow of new features into production in a safe and a secure manner. Happens that it's quite important, especially when the customer is a little bit cloud reluctant to moving to public cloud, that you don't screw up. Because if you do that, they may shut down your whole project, so you have to pay extra attention to keep your stuff secure and stable. The cloud provider that we chose was AWS, so I'll be talking about how we use that platform. So it's not cloud provider agnostic, but I wouldn't say it is particularly a lock-in either. So most of the other cloud providers have similar services, and a lot of the tooling that we use are across cloud provider agnostic. So anyway, I guess many of the principles will hold for all the other cloud platforms as well. So why is DevOps and moving to the cloud important? Because we think it's important. The reason is that today all businesses are IT businesses. So innovative use of IT is a way that all businesses get customers and deliver services to them. So if you're a car manufacturer, for instance, you're actually an IT company. You're not making cars, because when you finally one day think you're making car, and one day you wake up and suddenly you realize that you've hired 1,000 developers, then you actually realize that what you're doing is actually being an IT company, not a car manufacturer. So today's users, they are more demanding than ever, and they expect more and more. So in a market driven by this kind of competition, then the speed and the ability to change rapidly is the most important thing of all. So also for train companies, just to give some examples, there's a Belgian train company who let commuters shop groceries on their way home, while they're on their smartphone, while they're on their way home, waiting for the train. There are things like drones for surveillance of infrastructure or delivering better Wi-Fi, for instance. And of course you have gathering of all sorts of data from all kinds of Internet of Things devices, because railways has a lot of physical infrastructure. So everything from their main infrastructure and also stuff inside the carriages and such. And what happens to train companies when you get self-driving cars and Hyperloop? So they really have to start thinking about these things to stay in the market. So if you want to compete in such a market where more businesses are adopting these changes and you don't adopt these new ways of getting work done, you are really missing out. So it's happening now, it can't be stopped. And an important aspect is that this is not just for startups. The large enterprises and the public sector also have to take this seriously to not be left behind. So the advantages overshadow traditional requirements for security work. So you have to change the way that we work with security to keep up with the pace. Because security can't hinder that getting features into production fast. So change is in a way inevitable. And also with the DevOps movement and the demands from the customers to get to build better products, there's been a shift in the IT department. There's been a shift in the way we organize IT. So we're no longer separating between development of new things, maintenance, and operations. So everything is about development of new products. So for NSB, like all other companies, to gain competitive advantage, they need to innovate more, they need to experiment more, they have to get things out there before competitors, and they have to use a business methodology similar to lean startup, where you continuously learn by experimenting and measuring and pivot whenever the time is right for doing that. It's also worth to mention that a recent political decision in Norway has been to allow other train companies to enter the market. It used to be that they had a monopoly, Norwegian Railways. So that's why there's put more and more attention into this. So to be able to support the businesses to work like this, IT professionals like us, we have to be able to deliver quality continuously. So we have to be doing continuous delivery. And what is exactly continuous delivery? For me, it's not just about being able to be as fast as possible and get things into production all the time. That's continuous deployment. Continuous delivery is a concept where your software must be ready for production at any time. So long-lived development of new features, you can't do that anymore. You have to iterate. So we need to do this to support how business wants to work. So it's all about putting the release schedule in the hands of the business instead of in the hands of IT. And continuous delivery loves DevOps. But what is DevOps? As you maybe have heard all over the place at this conference, it has become something that means almost anything. Its original meaning is nothing else than this. It's about getting two disciplines that traditionally has been very separate to work together. But on our team, we have no ops. But no ops does not mean that there's no operations. It's just that the way we work has changed. So developers now have a much greater stake in the whole system. So Bekk, if you know him, he made XP and JUnit and lots of things. Quite famous guy. He was at the DevOps Norway Meetup it's many years ago, and he was actually talking about something slightly on the side. He wasn't he wasn't talking about DevOps. But since it was a DevOps meetup, someone in the audience asked him, what is your definition of DevOps? How would you define it? You have to remember this is many years ago too, so people were a little bit, what is this thing called DevOps? And he thought about it for a while, and he came up with this definition. Developers carry beepers, which I think is a really good definition. He's absolutely right. It must be the ones that develop the software that also must watch over them. So the reason for this is, of course, that they understand the systems a lot better than anyone else. And they understand the risks. And they are better off fixing problems when shit hits the fan. So, and another thing is that it also creates very good incentives for building things that don't break. Because no one wants to be woken up in the middle of the night. So if you let the team take responsibility for the system as a whole, you make sure that everything in the system is well understood. So the artificial boundary between operations and development, which I've always found is a bit artificial. We're all like IT professionals. So the team must be responsible for the whole. So that's why we, on our team also, we are on call, and we use the PagerDuty app so to buzz us if something unexpected happens in production. And also, this of course reduces handovers, misunderstandings, and it improves velocity. When it comes to methodology or process, our process is very simple. It's get shit done. I guess we're agile, whatever that means, but we don't use any particular methodology. Because what Agile is about is really about adaptability, right? And the ability to change and act on a world that is always changing. So we do such things as stand-ups. We have a task board that supports flow from ready and to production. And otherwise, we just get shit done. And DevOps loves cloud. Reason for that is that cloud, by magnitudes, reduces ops complexity. Because public cloud, when it comes to security, for instance, it has so many security advantages. The cloud security vendors, they are putting a lot of effort into securing the cloud. And I understand that that's a very important thing for them. So Forrester expects this trend to accelerate as security becomes a more critical selling point from the buy side. So in the cloud, you're just able to just specify your security requirements, and automation takes care of setting everything up the way you prefer it. So large vendors, they will most certainly fix security issues the fastest than anyone else. And white hat hackers will constantly seek out to find security issues in the big cloud platforms. And also, of course, evil hackers. So we will have incidents, but we will get them fixed a lot more faster than for systems in our own data centers. So enterprises will achieve better security this way than on their own. There's some principles for harnessing the cloud. You can't just trust the cloud and don't think about anything anymore. So Amazon is talking about the concept of security of the cloud versus in the cloud. Security of the cloud is quite good. That's where the cloud vendors are really brilliant. But security in the cloud, you have to take a small part of responsibility for. So if you host your services on premises, then you of course have to manage your whole stack. That's your responsibility. Everything from machines and up to the applications. If you decide to use a cloud platform where you abstract away the hardware using virtualization platform, you still have to care about like OS and all the way up. Then you can move one step further and go for platform as a service. And then the cloud vendor also has responsibility for the security of the runtime. And you have to just worry about applications and data. And even better, when you go for software as a service, then you're basically buying a product that's ready built. So the responsibility is on them. So what we wanted to focus on when we were doing this shift, to be safe and secure, we wanted to focus on that end of the spectrum. And that says dead end over there. It's a bit narrow, this projector. But public cloud is really the future. I mean, there's so many advantages of putting your stuff out there instead of trying to build your own internal cloud. And it's not just elasticity, reduced cost, and cycle times, and that you have the best operators in the world, because the best operators in the world, they work for Amazon or Google or Azure. They also innovate faster, launching new services all the time. So my suggestion is just buy and use services that they have instead of rolling your own solutions. If you need a database, don't set up a server and install a database on it and do all the maintenance, all the backup and all that shit. We don't want to do that because it can be bought. And there's more and more services coming all the time. It's hard to keep up, actually. Another principle is that automation is extremely important. Luckily, the cloud vendors support this very well. They have APIs for everything you can do in the cloud. So automate against APIs instead of fiddling around in prod, because then you lose control over what is what, and you can get snowflakes in the cloud too. I'm feeling I'm breathing very heavily. So now I'm going to talk about the juicy part. I've been talking about the principles and like how we view the world around DevOps, continuous delivery, that like the principles of the cloud. Now I'm going to talk a little bit more about like how we did stuff. So I'm going to show you our repos, how we structure them, and also some code. And at the top level, we have two repos, one for infrastructure and one for application infrastructure. And then we have repos for, of course, all our apps. Our apps are quite small, so you can call it maybe to define stuff as a microservice, that's really hard. But they're like medium-sized applications. So they're not monoliths, they're not maybe microservices either, but they're quite small. So in the infrastructure repo, we have the basic infrastructure. In the app infrastructure repo, we have modules that are reused between applications. Not all modules are useful for all applications, but many of them are, like a database, for instance. Yeah. So let's talk about infrastructure as a service first, because you need some infrastructure as a service. You need some basic infrastructure. Or at least I would recommend it, because I want to have certain control. Just deploying into the default VPCs, default networks and such, that can work for a while, but you really want to be able to set up separate environments, like for prod, test and such, so you want to separate these. So then you need some basic networking infrastructure. So in that repo, we set up such a things as everything that has with networking. And we also set up a Bastion host or a jump server, which is a server. I'll talk a little bit more about that later, but it's a server where you can access all the servers inside your private subnet. So it's the only entry point for a developer to get in to log on to servers in production. And that is, of course, hardened, and it's just the SSH proxy. It's actually not possible to log on to that server. You can only jump through it to reach other hosts. That's our most valuable entry point. If someone gains access to that server, they can basically get access to all our infrastructure. We also have what we call a management server inside the private subnet for doing administrative talks. We do some backups of some file systems there and some cron jobs, but we're not really happy with that solution because we want immutable infrastructure. We don't want to fiddle around in prod. But since we're moving legacy applications, it's been really hard to do that. So for all our new cloud native apps, we don't have to log on to them, we just create new. But when you're setting up like a CMS Anonic cluster where you have to have you have to know the IPs of the other machines and stuff, and you have to have a file system that's shared between the hosts and things like that, then it becomes hard. So you need to have some operations. But that also should be automated. So we actually don't log on to the servers inside the production environment, but we script against those servers. And the tool we're using for all this is a tool called Terraform. And Terraform is a tool for creating, changing, and versioning of infrastructure in a safe, automated, and effective manner. So what you do is that you describe your infrastructure in code, and then you generate an execution plan based on your changes, which describes what Terraform will do when you provision something to reach the desired state. And when you make changes, then Terraform finds out what the change is and it executes the change incrementally so that you can evolve and refactor your infrastructure like you would refactor your code. So Terraform is infrastructure as code. So it is perfect for documentation. That's the only true documentation is in the code. It's really readable too, so you can almost hand this over to a business person. But then again, maybe not, because maybe he doesn't care too much about networks and stuff like that, so you have to understand those things. Anyway, so and it's also easy for sharing. You can share modules between teams and open source them, of course, and reuse them. And it generates execution plans, which shows in detail what is to be executed, which of course avoids surprises. So you should check your plan before you actually execute it. It also creates a resource graph with dependencies between stuff. So it respects dependencies, so it parallelizes where it can to be faster, but then again, sometimes you need to create something before you can create something else. So it generates an execution plan based on what is needed. So you don't have to have that in your head. Yeah, and it automates everything, which takes the human out of the equation, and we know that nothing is better than taking the human out of the equation. So the infrastructure repo sets up the basis infrastructure, like networking, the Bastion host, and management server. So that's basically what that does. So we want to keep that at a minimum. Looks like this. You separate between environments. So you can have like prod, test, QA, and such, with a main file and a variable file, and then you have modules, and you include those modules in your environment. So it looks like this. In Amazon, you have a concept of a VPC, a virtual private cloud, which is it's a virtual network which is dedicated to your AWS account. So you can think of it as an isolated part of the internet that is reserved for you. And this is a code for setting up a VPC. It needs an internet gateway and a routing table to gain access to the internet. You could have a VPC without access to internet too. That would make sense in some situations. But we are making web applications and apps, so we need to have access to the internet. And also Amazon EC2 is hosted in multiple locations worldwide. And each region is a separate geographic area. And ours is hosted in Frankfurt, because that's the closest to Norway. We're getting a data center in Sweden now, so we're probably migrating to them. And in each region, we also have multiple isolated data centers, which they call availability zones. So EU Central 1A and 1B are isolated data centers. So you should spread your applications across at least 2. And after you've created a VPC across 2 availability zones, you create subnets. You create public subnets, which are accessible directly from the internet, and you create private subnets, which are only accessible from applications and via the Bastion host. So, and this is an example of how you're reusing a module for creating subnets. So here you have some variables, and you have a counter. So you can just specify a counter of how many subnets you want, and you spread them across different availability zones. So there we have our subnets. A public and a private subnet in each availability zone. And then there's the concept of the databases, because the subnets actually you don't have like an actual connection between them. Or you don't want that. Of course, you can set up a connection between the private subnets. When it comes to the database, you need to be able to fail over. You need to have something called a DB subnet group, which spans across the 2 private subnets. And what you basically need to do is that you have to create a DB subnet group, and then when you request a database from Amazon, it will automatically, you don't know which availability zone, I guess you could specify which availability zone your database would go into, but anyway, we set up a standby server inside the other private subnet. So, and it handles like the failover automatically. So it's just magic. I actually don't know how it works, but I don't care because it works. So it looks a little bit like this. For setting up EC2 instances, you can create a reusable module. So this is the module that we use for our Bastion host and our management server. Same thing, use variables, specify which instance type you're going to use, like the size of the machine. Yeah, it's actually quite simple. So now we have a management server inside the private subnet, so that's not possible to log onto from any place else than from the Bastion host. We need to put the Bastion host in the public subnet. What you can do in addition is to have a VPN or something, or specify an IP range that can log on to that Bastion host. That would make it even more secure. Or use 2-factor authentication. And then we can't just like set that up and make them available to the whole world. Actually, by default, it's not available at all. So that's good. You don't start with everything open. You start with nothing open. And then you have to specify security groups. And security groups are a little bit like firewalls, but they're instead of having like a central system where you manage all your firewall rules, you create like security rules and they're like atomic instances. So what we do here is that we create a security rule for the management server that it will allow SSH from the Bastion host, nothing else. No other server, you can't SSH from anywhere else. And for the Bastion host, it can only SSH to the management server. So we can SSH into the Bastion host, but we can't SSH anywhere else than to the management server. Or we can set up rules to be able to access application servers too. You want to restrict that as much as possible. So this is how it looks with security groups. And there's an important point there, because you can secure your VPC at all the edges. So you can sort of create a firewall around everything and restrict the access by that manner. But when things become complex, you want to have security on all layers, not just the edges. That's why you want to set up security between all your resources in the cloud. So you want to set up security rules across all your services. So for a database, for instance, you should set up a specific security rule for your application to the database, not just count on that the security of your private subnet will be sufficient. And then we have the Bastion host, and the developers have access to log on to that server. But you should have SSH audit. So you want to know who has been inside your network and what they've done. You want to know that. So and of course, if something happens and someone breaks in, you want to know that, and you can set up alarms. So we have to automate that in a way, because we don't want to, every time a developer starts, we don't want to log on to that server, add that user and such. So we want to automate that. In Amazon, you always get a key pair. When you create an instance, you get a key pair and a default user. And many use that key pair and have like this one user, and they use that for doing all their stuff. But that is, of course, not a good idea to share keys. So you need to create personal users on the Bastion host, and you have to audit it, and you need a way to automate that. It should be easy to add new members to the team. So we've automated that, and I'm kind of proud of this solution, because it's not Amazon doesn't do this out of the box. But we want to be able to create users in one place and nowhere else. So if we remove a user, then it gets propagated to all other systems. So we create ordinary users in IAM, and we assign them to a group, for instance, developers or the persons that should have access. And they upload their personal public SSH key. And then we have a cron job on the Bastion host, which has a role, and it's only that server who are allowed to download these keys from the server. So the Bastion host downloads the keys whenever there's a change. And then the cron job also creates all the individual users for each developer, and then adds the key to authorized keys on their user. So removing, yes?
Do you need to propagate the keys to particular machines in your application?
No, we have chosen not to do that, because we say that it's enough to know who has been logged on when. And we also have an audit log of everything that happened with our applications, because we have monitoring of things. We know this person has been in between such and such. And that's, of course, that would improve security. But to be able to be compliant to the stuff that we have to be compliant for, this is actually enough.
How are you able to access the other servers other than the Bastion host? If only the Bastion host.
Yes, then we use the common user and we forward the key from that. So you can't be able to log on to the Bastion host with the shared user. You can only log in as yourself. But when you're jumping to the next host, you can use the shared user. Yeah. Yeah, so when you remove the developer from IAM, it finds out and it deletes everything from the Bastion host. And then we also stream important logs from the Bastion host, like varlog secure or varlog messages, so that we can see, have an audit of that. Yeah, as I mentioned, the users are not allowed to log on to those servers. They're only allowed to jump through them. So if they gain access to the Bastion host, it would have been possible to do something. Of course, they don't have sudo, but they could do stuff, so they're not allowed to log in at all. So now let's look at some tools that we use to automate and simplify and secure infrastructure and applications. And these are tools that sort of doesn't have anything to do with cloud specifically, but it's tools that we have used to simplify security, so that doesn't hinder our productivity and our ability to roll out fast. I don't know if you recognize those, but in some of the code that we saw, we have some secret variables. Like, for instance, a password or something. You need to have that sometimes because the applications or the DB or something needs a password. So, and to automate insertion of secrets, we have put together some tools. We have created a wrapper around Terraform. Terraform is a command-line client, but to add functionality, we have written a wrapper in Go to manage securities, because Terraform doesn't do that out of the box. So you have to find some solution. The wrapper, it expects a file called cloud-config.yml, and what that does is that it handles variables in different ways. Some plain variables, and some secrets, and some dynamic. And you can see that variables, they are prefixed with tfvar. That's basically a convention for Terraform, that if a variable is prefixed with that, it's a Terraform variable, and it picks up as such. And secret variables, they use a tool called password store, which is a command line tool for encrypting secrets. So let's have a look at secrets variables first. But first I'll introduce this nice tool that we use for secrets, because it can be used in many ways. So it's a command line tool for password management. There's also alternative tools like Git Script, which is a little bit similar. And what it is that it's a file system with encrypted files. So it's just plain files. So if you do an ls or tree on your directory structure, it looks like this. And we have all our secrets, and they're all encrypted. And then I use the command line tool. For instance, to show a password, and the -c option there, it is so that I should copy it to my clipboard instead of writing it out to standard out. Someone is hanging over my shoulder. and then I get prompted with this. And what's cool is that to be able to see this password, I can use my own GPG key and my own passphrase for that key. Because all the passwords are encrypted using all the developers' keys. So that you don't have to have like a master password that you pass around or everyone has to know or anything like that. You just use your own personal GPG keys. And when a developer is, a new developer is coming to the team, or a developer is quitting the team, then we just re-encrypt all the passwords with the keys we then have. Yeah, it pastes it to the clipboard. And then there's another cool tool. Yeah. Yes, we committed to Git. Yep. So everything in Git, also passwords. Yeah. And then another cool tool is env-chain. You have to be on a Mac though to be able to use this tool, but there's maybe a different tool for other platforms, I don't know. Because I think all the cloud vendors, they're dependent on a key set that each person that is working on the cloud has to have. And very many put those as environment variables. Because then all the tools, the clients you use, they can check and see if there's environment variables for that. So that's the simplest way. Or even worse, you can put it in a config file, your private credentials. That of course can be stolen, so you want to avoid that. So what we do with env-chain is that we're using Mac OS keychain functionality. So to create a new environment variable set, you use this command line. I want to set under the key AWS, I want to set AWS access key ID and AWS secret access key. And you get prompted for the values, so you paste in everything there. And to use those variables, they're not in your environment, but if you type env-chain AWS in front of any command, it will be injected into your environment for that command and that command only. So if I press env-chain AWS and then env is the command that prints out all your environment variables, I will get them. But if I just type env, they won't be there. So if I'm going to execute Terraform, I need my credentials. So then I just type env-chain AWS and the Terraform wrapper command. And another security measure is that if you are provisioning against prod, you should always type prod with large letters before continuing. Because at least I think many have thought they were provisioning test and then, oops, I was prod. Has happened. Not to me, of course. That's why I wrote this extra feature. Yeah, and then Terraform runs. So let's move over to the app infrastructure repo. And the app infrastructure repo sets up all kinds of things that are common to most applications, like databases, DNS, certificates, SSL certificates, file systems. EFS is sort of like NFS, S3, CloudWatch for monitoring events, logs, and everything. CloudTrail for audit. That's actually what we do with the logs from our server. We send them to CloudWatch, and CloudTrail can you can set up monitoring and alerts in CloudTrail. And also IAM, Identity and Access Management. So everything is automated. And many people would maybe not call this the software as a service, because a software as a service is sort of like a complete product, many people will say. But I don't know where to place it, because it's not a platform as a service either, because we don't add our own functionality. We use services that are fully featured. So I call it software as a service. So the common for all of these is that you don't need to think about operating them. You just have to automate the setup of them. So backup, mirroring, patching, scaling, and all this is handled by AWS. That's why you should see if you can find something that AWS has before you start rolling your own. That repo looks like this. You don't have all the applications there because these are just modules that the applications include from each repo. So most will use a database and DNS and certificates. Those are examples of things that all applications use. But like NFS, having state on a disk is actually not a good pattern, but some of our applications needs that, and then that's why not every project reuses those modules. And what's cool also is that Terraform is cloud agnostic to a certain degree, but it's also, for instance, database agnostic. So you can have an AWS DB instance, and you can set up like all sorts of flavors. So we have both MySQL and Postgres, but we use the same module for specifying that. And Amazon RDS, it manages backups, software patching, automatic failure detection, and recovery if something goes wrong. And it's multi-availability zone. So it has a standby in another availability zone, like I was talking about. So when we provision that, we have this. You don't ask for standby or which availability zone the DB should go to, but you specify that it should be in the private subnets. We also, of course, have to mention use the AWS Command-Line Client a lot. We don't want to fiddle in the GUI and look up information in the GUI. We want to use the client because it's so much faster and it's excellent for scripting. Because it's not always easy to find like an ID of a server because that's just some random name. But you can tag each instance in certain ways, and then you can query for IDs and IP addresses and such with the command line client. So we use that quite extensively when we're scripting. And then the applications, which are the platform as a service. This is where we write our business functionality, what creates value. The concept there is that we want to move from pets to cattle. We want to be able to create servers, tear them down. So if we don't patch or deploy software or do anything to these servers, we create new servers all the time. That's my cats, by the way. If one of them died, I would actually be quite unhappy. I don't know. I'm not a farmer. They're probably not like their cows dying either. But anyway, they have like a life cycle that's different from cats. So Elastic Beanstalk is sort of the icing on the cake of this whole platform. It does everything that you would normally do in Terraform. So we started out setting up all this ourselves with EC2, setting up load balancers and networking and scaling and all those things like that. You can do that in Terraform, but Elastic Beanstalk does all that stuff for you. So that's what makes it a PaaS. We don't use Docker. Many people find that strange for some reason. You could use Docker in Elastic Beanstalk, but it simply doesn't make much sense for us. So we have around like 10 services running. Let's say we double that to 20 or something like that, and then you sort of have 3 of each service. It still isn't very many servers. So maybe like 100 servers or something like that. It's not very many. So like large scale orchestration of like thousands of servers, that's not necessary for us. And we are using Java. So Java is actually, it's containerized, it's a contained process in the JVM. So I don't see the point of wrapping a container inside the container just for doing it. And also we're using micro instances, like the smallest virtual machines that you can buy on Amazon, and they cost very little. So if we were to buy bigger machines to host a lot of Docker containers on them, it would probably cost us more, because those big boxes in Amazon are really, really expensive. So Elastic Beanstalk, its sales pitch is easy to begin, impossible to outgrow. And what it does for you is that it automates and manages configuration, deployment, capacity provisioning, load balancing, auto-scaling, and monitoring. You get all these things just by using the framework. And it doesn't cost, using Elastic Beanstalk doesn't cost anything in itself, but you have to pay for the resources that it creates. I don't know about if it's impossible to outgrow, but it certainly is easy to begin. So an app repo looks like this. You have a proc file, which is your startup command of your application. We have created scripts, create, deploy, and terminate, which you have standardized across the applications. I'll look at that soon. And EB extensions are, if your path doesn't, if you want to change some configuration of your path, you can use extensions to Elastic Beanstalk to handle that. So for instance, setting the time zone on the machine, I will create an extension like this and put it in the EB extensions folder. Or setting up my certificate, SSL certificate, on the load balancer, I will also specify that. I specify that it's the port to connect to on the instances is port 80, and the only port to listen to is port 443. You can also set up some logging. If you have some specific logs that you want to stream to CloudWatch, you set up that and how many days it could keep the logs and such. The proc file is quite simple. It's basically that. That's the startup command of the application. And Elastic Beanstalk Client, EB, has basically 3 important commands, and that's create, deploy, and terminate. So what we did, our scripts are wrappers to fetch things like metadata about which VPC are we going to deploy to, what DB are we using, which subnets are we deploying to, and things like that. And that's where the AWS client is good to fetch those IDs and set them as parameters to the EB create command. So what did we just create with these tools? We created this. I just want to mention the tools. This tool for creating these wonderful diagrams that you can actually show to an enterprise architect is that it's auto-generated from your AWS resources. It's called VisualOps.io. Only works for AWS, unfortunately. And I think the cloud vendors should actually invest in this to be able to get an overview of how your whole infrastructure in a nice setup like this. So I'm running a little bit short of time, or am I supposed to stop? Anyway, I don't have much more, so bear with me. So this is sort of summing up. There's a lot of stuff that I didn't mention around security. And these are really, really important points. So application level security. The cloud vendor does not ensure that your applications are secure. You have to manage that yourself. So the cloud vendor can't protect you against cross-site scripting or SQL injection or so application level security is something completely different. I've been talking about infrastructure. Security culture is a very important thing. You have to work inside your team to build a culture of secure coders that always think about security, and we discuss it a lot. And there's quite a good incentive, because if you say like, if we're not secure and someone can find that our security is not good, then maybe we can't work with cloud anymore. And then the developers get like, they wake up and yeah. And there's also a bunch of things that I probably forgot about. I mentioned some other services that we use that are software as service outside of AWS. There's a tool called Panopticon, which is great for where you want to monitor from the inside out. So you bake your monitoring inside your applications, like test-driven development, only it's monitor-driven development. So if you want to monitor something that you find is very important inside your application, you add some code around that, and it posts to a server where you can get an overview of the health of your applications. Use Auth0 for authentication for some services. Ping them for external monitoring, because you want to ping from all around the world, not just ping, but log on to your solution, for instance, and see if that works. That's the only monitoring that actually matters for your end users. Use PagerDuty for paging us. Use Slack intensively for chatting. GitHub for everything, also secrets. Use Travis CI. Don't need to maintain your own Jenkins server. That's just foolish. We use Ansible a little bit for configuration management and scripting instead of using bash scripts. It's quite powerful. Also started experimenting a little bit about lambdas for mostly like development work, for posting events. No, it's actually for monitoring stuff happening in your environment, and it posts it to Slack. And we also created our first Lambda service recently, which is a service for calculating emissions of different transport. Like, for instance, the train is much more environmental than using your car, and then you can see the difference. We're using Lambda for that. Summing it up, I've been talking a lot now. It's been a little bit technical. So how do we pull all this together? What did we learn? That guy is actually sitting there. The guy screaming. We found out that you should reduce infrastructure as a service to a bare minimum. Don't fool around with all these details. You have to have some infrastructure, but as little as possible. Use hosted services where available. These guys have made wonderful products, and they're a lot better than you ever be able to create your own yourself. So just admit it. Use PaaS for services and application and for your custom code where the business value lies. Automate, automate, automate. Everything should be automated. Monitor, monitor, monitor. You need to know what happens inside your environment. What the hard part, migrating to the cloud was actually, I'm not bragging too much, but it was actually quite easy. But migrating existing applications to the cloud that are not cloud native and they haven't been built for the cloud, that is the hard part. That was what we struggled with. So what did we gain? We can now understand security because we're responsible for security, also operational security, which we're not used to when we had the operations department and the developers separate. We have insight in everything, which of course is an advantage. And I find that the hard parts, they're actually the cloud vendor's responsibility. those things that we find to be difficult in without using the cloud. We get prod equal environments on demand. It's just a click of a button. You get a prod equal environment. Elasticity and auto-scaling without investing in hardware before you start. Reduced lead time. Everything goes faster when you have this set up. And that actually enhances agile business development. So we can see actually the effects of the technical stuff that we have done has enabled the customer almost automatically to become more agile in the way they develop their business. So it's important for us developers to show the business what they can gain from this. And they love it. We get ownership of what's delivered. We care about all the stuff we do. We monitor it. We get woken up at night and we fix it because we don't want to get woken up in the night. So responsibility is basically in the right place, where it wasn't that before, but now it's in the right place. There's less stuff to remember. You don't have to have insight in all the bits and pieces, because a lot of the complicated stuff is hidden from you. And also very happy employees. It's one of the projects where people are really happy. Some plans for the future. We have to rewrite all these we have taken applications and lift and shifted them into the cloud. They don't really fit, so we should rewrite these to become more effective. We have found that microservices, creating smaller and smaller services, is actually a perfect match for what the railways are wanting to achieve. So we will probably reduce the size of the services also as we go. More serverless or functions as a service. To the management server we don't really like, so we want to get rid of that and automate stuff with lambdas instead. So, like the CIA found out, it's probably better to buy innovation than to do everything yourself. They're on Amazon. And like NASA realized, you are probably a lot more secure in AWS Cloud than you are in your own data center. So that's it for me. Thank you very much. Are there any questions?
Will the slides be available?
Yes, they will. I've been told to hand them over to the committee, but they're also there. It's probably a little bit hard to remember that. I can tweet it after too. I'll do that.